This question is on kinematics and dynamics. You are given a resultant time graph. Okay, that's not common, but a resultant time graph. And the resultant force on an object that causes it to move in a straight line. The graph here shows varies with time. Which graph is the speed time graph for the object? Now let's assume a context of a car which might be easier to understand. The car is moving to the right, and let's give it a value. Let's say the forward thrust of the car is 300 Newton and the total resistive force is 200 Newton. So am I right to say Fnet equals to MA? And because the thrust is greater than the resistive force, so 300 minus 200, that will be the mass of the car and there will be acceleration. So if then this, okay, so here you can see that the resultant force acting on the car is going to be, right now is 100 and it's decreasing. That means to say you can treat it as now the car, you're going to slowly reduce to, from 300 you reduce to 200, which is the same as the resistive force as the car is moving to the right. So if the forward thrust is decreasing, that means to say the net force is decreasing, and therefore since mass is constant, the acceleration of the car, of the object, will be decreasing. One thing to take note, acceleration is decreasing does not mean it's slowing down, decelerating. It just means that the speed is still increasing but at a slower rate. So the increment is getting lesser and lesser as time goes by. So let's also consider speed time graph. The gradient of a speed time curve is actually your acceleration. All right. And since we has established that the net force is decreasing, that means the acceleration is decreasing. So it's very obvious that D will be the answer because the gradient is decreasing. Therefore, acceleration is decreasing. So let's go through the other option. This is constant acceleration, no acceleration, constant speed. So the first part from 0 to T0, that is wrong already. So this is a deceleration, constant deceleration, which is wrong. All right, remember I said, so the net force is decreasing, it is still undergoing acceleration. It's just a decreasing acceleration. So the speed does not decrease. So this is a decreasing deceleration. So that is wrong. Then some of you might wonder, how about here? Since they put it here, you can also assume as it continue, the net force is equals to 0. Okay, equals to 0. So net force equals to 0. That means to say your acceleration will be 0 also, which is, that means because the car is already moving, and when the two forward thrust and the resistive force are equal and opposite, the net force is 0. The car will continue to move at a constant speed in the straight line. All right. So I hope you understand the question now. Thank you.